Hello, this is Mr. Precella, and today we're going to be looking at some applications involving exponential functions. We're going to be using our calculator, and so to punch in an exponent, there's a little caret top key right there. For instance, if I need to know 15 to the fourth, 50,625. But that's a key we'll be using. Let's see. So just jumping right into these word problems. Oh, problem number one, it says that there's two keys on your calculator that for exponent. There's a y to the x or the little caret top symbol. And let's see, it says the exponential function f of x equals 559 times 1.032 to the x models the population of a country, f of x, in millions, x years after 1972, sorry. So without using a calculator, substitute 0 for x, and without a calculator, find the population in 1972. See, x is the number of years after 1972. Can y'all read that? Do I need to zoom in a little more? There, yeah, that's what I need to do. Let's see, okay, there. So, part A. I'm plugging a 0 in for x. That's 0 years after 1972. It says without using a calculator. Well, this is the one you can do without a calculator. Why can we do it without a calculator? Well, we know a rule about a zero exponent. Some number to the 0 power is going to be a 1. Remember that rule we had? Anything to the 0 power is 1, well, except for 0 to the 0 power. So if 1.032 to the 0 power is 1, we just have 1 times 559, which would be 559. So the country's population in 1972 was, well, not 559, but rather 559 million people. That's a pretty big country. It's certainly not the United States we're talking about. Now let's see part B. Substitute a 22 for x and use your calculator to find the country's population in the year 1994. Notice x is the number of years after 1972. So if you added 22 to that, that would give you 1994. So B, we'd have 559 times 1.032 to the 22 power. Let's see. So plugging in 559 parentheses 1.032 close parentheses, little caret top, 22. So 1,117.8. How are we told to round this? Okay, so we're rounding to the nearest million, which means we want this just as an integer. So how would we round this to the nearest integer? Would it be 11, 18? Yeah. 1118. Now that doesn't mean the country has only 1,000 people. It means it has 1,118 million. In other words, 1,118 million people. So this is certainly, ooh, the lights. There's nothing wrong with it. It just went blank for a second. Nothing wrong with your computer. Now, C. Find the country's population to the nearest million in the year 2016. Well, here they didn't tell us the X value. X is the number of years after 1972, so you're going to have to subtract 1972 from 2016. It tells us that X is the number of years after 1972. Since they didn't tell us the X value here, we've got to calculate the X value by subtracting. And what would that be? Is that 44? Now, plug 44 in for X. So in place of the X, I'm putting 44. And we stick this into our calculator. 559 parentheses 1.032 close parentheses raised to the 44th power. 2,235.2. Well, because of the 0.2, we'll just round it to 2,235. If it had been a 0.5 or larger, we would have rounded it up. So just, wow, this country is really big, isn't it? 2235. Okay? So it's in the year 2016, we're expecting that country's population to be 2,235,000,000. Remember how to read out your numbers? 2,000 million would be 2 billion. And D, this is one of those problems that won't end. It keeps going and going. D says, okay, do the same thing for the year 2038. So let's calculate X. 2038 minus 1972. Is that a 66? So plugging a 66 in for X. 559 times 1.032 to the 66th power. 559 parentheses 1.032 raised to the 66th power. 4. Now, am I going to leave that as 69 or make it 70? Make it 70? So, countries isn't 4,000. The population of the country isn't 4,470. It is 4,470 million, which would really be 4 billion. Oh, wow. It's a huge country. Now, E, what appears to be happening to the country's population every 22 years? That's what we were looking at. This is every 22 years. 0, 22, 44, 66. So let's look at these answers and see. 559, what does it look like? Okay, is it growing by a factor of 2? That would be doubling every 22 years. No pattern. C, a factor of 3. Are these things tripling every 22 years? Or is the population decreasing by 1/2? Well, the population is certainly not decreasing. In fact, if you just sort of multiply each one of these numbers by 2, you get pretty close to the next number. And so I'm going to say A, the population is growing by a factor of 2. It's doubling every 22 years. Now, this is better here. This one. Number 14. I think this is based on Chernobyl. The 1986 explosion at a nuclear lab sent 1,000 kilograms of radioactive element into the atmosphere. the function f of x equals 1,000 times 0.5 to the x over 30 power describes this amount. Describes the amount f of x in kilograms of a radioactive element remaining in the area x years after 1986. So x is the number of years after 1986. If even 100 kilograms remain in the atmosphere, the area is considered unsafe for human habitation. Find f of 80. So that means you're looking at 80 years after 1986. 80 plus 1986 would be 2066. So let's find f of 80, and then we're going to determine will the place be safe for human habitation in the year 2066. So this is a little tricky when you punch this into your calculator. If you're using a calculator similar to mine, you're going to have to put these exponents in this exponent in parentheses. If you don't, then it's going to follow the order of operations, which is parentheses, exponents, multiply, divide. It's going to treat the only exponent as an x, and then later on divide by 30. But no, you want it to divide that x by 30. So in order to indicate that all of that's in the exponent, it's going to have to be in parentheses also. So I'm going to have two sets of parentheses here. I go 1,000 parentheses 0.05 close parentheses. No, I'm sorry. I messed up. That's 1,000 parentheses 0.5 raised. Ooh, can you see that? Raised. Now here's the tricky part. You've got to put that the exponents in parentheses. Parentheses 80 divided by 30 close parentheses. Notice how I put that exponent in parentheses. So 157.49. I wonder how we're told to round this. Let's look and see. Oh, it says, so we have 157.49 ... The instructions say type an integer or a decimal rounded to the nearest tenth. Well, we don't have an integer, so we need to type it as a decimal rounded to the nearest tenth. So that's going to be 157.5. So 80 years after this explosion, there's 157.5 kilograms of radioactive element in the atmosphere. Then it asks, okay, will the area be safe for human habitation? Let's see. What do we think? Is it going to be safe or not? Well, let's see. It had said that if there's even 100 kilograms remaining, it's considered not safe. So will this area be safe? Well, no. Now there's two of these that say no. Which one's the right one? No, because the element remaining is greater than 100, or no, because the amount remaining is less than 100. Well, if it's less than 100, it's considered safe. So we're going to choose no. Will the area be safe for human habitation? No, it will not, because there's more than 100 kilograms. Wow, these problems here are just full of happy topics. nuclear explosions and radiation contamination. The first one dealt with world overpopulation. Okay. And now we're ready for the last one, which deals with inflation. So today we're just really talking a lot of happy thoughts. Okay, so number 15, an inflation model. The formula S equals C times 1 plus R to the T models inflation, where C is the value today. So C is the value today. R is the inflation rate in decimal, okay, form. So it's the inflation rate in decimal form. S is the inflated value. So S is that future inflated value. And T is the number of years from now. So let's see. If the inflation rate is 3%, well, that's R, the inflation rate, but you're not going to write 3%. How do we write a percent as a decimal? 3%, you move the decimal point 2 places to the left, you're going to use 0.03 as the inflation rate. So if the inflation rate is 3%, how much will a house now worth $86,000? So that's the value today be worth in 7 years. So we're going to plug an 86,000 in for C. 1 plus R. Plug a 0.03 in for R. Don't use a 3 to the T power. So we are plugging 86,000 in with a 3% inflation rate to see how much will that same house cost 7 years from now. This is inflation adjusting. I have a little app on my phone. My friends always laugh at me because I'm always inflation adjusting a number. Okay? People talk about, whenever I hear any sort of money value, oh, how much was that in 1987? Or, okay, well, that cost $20,000 in 1987. How much would that be today? So I have a little app on my phone that inflation adjusts based on the consumer price index here in the United States. So plugging in 86,000, parentheses, 1 plus 0.03, raised to the 7th power. How are we told to round it? Round to the nearest dollar. So if we were rounding it to dollars and cents, we'd say $105,769.15. But since we're told to round this to the nearest dollar, $105,769. $105,769. Okay. So we can expect that same house that was worth $86,000 today to be worth this much, $105,769,000 in 7 years. Okay. So I was just looking over, doing a few word problems involving exponential functions, world population of a country, radioactive waste, and inflation. So thanks for watching, and I'll be talking to you later. Thanks. Bye-bye.